Hello everybody, Mr. Noyes here to talk to you guys about the lesson for the day today, domain and range. For starters, we have two definitions for you. The domain definition, the values for x that are the input values for a function, they're the x values from a coordinate pair that you would have. The range will be the values for y that are the output values for a function. They're the y coordinates. So x is going to be the inputs and the y is going to be the output. The x relates to the domain and the y relates to the range. We'll be seeing a couple examples on the next slide. With these examples here, we're going to go through, we're going to pull out the domain values, we're going to pull out the range values. So we have three examples, first, second, and third example here. For the first example, we're going to go ahead and we're going to write it as the domain. So for starters, we want to make sure that we have the word domain written down. Domain. I'll put a colon afterwards to go ahead to talk about what we're going to be having following that. Inside here we'll be putting down little squiggly brackets, as we may call them, or pointed parentheses to note it's going to be a set of numbers. And the domain again was your x values. So we're going to have the x values be pulled out from the coordinate pair that we have and placed inside here. So they'll go a 5, -5, 7, and 0. So our domain for this set of numbers here that we would have would be 5, -5, 7, and 0. Our range would be the same exact idea. We're going to go ahead with for the y values. We'll pull this out with red. So range, a y value there, 2, 4, 9, and 0 again. In the set that we have for the range will be denoted as 2, 4, 9, and 0. So we have this as 2, 4, 9, 0, which is going to be the range, domain, 5, -5, 7, and 0. So the next question would be going through then and would define whether or not if this is a function. Do we have more than one x value per y value? And you'll be able to see here that this is going to be a function. If we were to look at that, if we were to see this as a graphed set of points, we would see it would follow through with the definition of a function. The next example right here, we would see that we have this labeled out as a table. X values, y values. These values, -5, 7, they go together. They're the coordinate point that you would see from there. So let's go ahead here and find the domain for this problem. Let's find the range. This was example number 2. So again, our domain is going to be all x values, -5, -4, -3, and -2. So -5, -4, -3, and -2. Sorry about that, a little close to the edge there. Range is going to be your y values. So again, pulling them right from our table, y values, 7, 12, 17, and 22. So 7, 12, 17, and 22. Again, we want to make sure that we're not putting parentheses around these because that would represent the idea of graphing a point. So we want to make sure you have it as the squiggly brackets, as they may call them, or your pointed parentheses. Question would be then, is this a function? Does this have just one x value for each y value? No more than one domain paired with a range, another way of hearing it. And you'll see that yes, every x value is only used once, so we're good there. Alright, example 3, move this up here a little bit for us. We'll do this in red today. So our domain, same thing as what we were following through here. Our domain, and then our range. Alright, so your domain is going to be the x values again. X value, 12, 2, and 12. So here's a good question. Do we write down 12 once, or do we write down 12 twice? Well, to help you out with it on this video today, we're only going to be writing down 12 one time. We do not write it down twice. The number 12 is the number 12. It does not appear more than once in the set of numbers that we have. So we would see this as a 12 and a 2 here. And our range would be the y values. So it's going to be a 2, a 12, and a 4. Alright, so we have our domain, we have a range. We're going to ask you the same question again. as we found out that we were saying this was a function. We're also saying that this was a function. Now the question is going to be, is this set of points here, this function that we're just saying, is it going to be a function or not? Does this follow the definition? Well, you can see that in fact we have two 12s, which is an x value being used more than once. So for this example, this one will not be a function. No, this is not a function. So you say not a function. Okay. The next slide, we'll go ahead to take a look at some graphs that we would have here. For this first one, we're going to have a picture of a circle, and we'll have two more after this. For this circle here, we're going to go ahead to find out what the domain and what the range is going to be. For this circle, the domain is going to be your x values. Again, remember. So we're having an x value here. We're having an x value here. This circle, centered at your origin, hitting around at all of the points that we would have being on the line of the circle. We know that the circle does not go anywhere beyond this point here or beyond this point here. This point is 1, 2, 3, 4, 5, 6, 7. So it's going to be a negative 7. And we would have this, of course, being a positive 7 over there. So if I were to go ahead and fill out what my domain is going to be, for this circle, you would see that your domain is going to be between negative 7 and 7. All right? So from here, we're going to go ahead to make sure that we're able to write this as follows. Negative 7, 7. And the x values that we're talking about are going to be, of course, x. So I have to have that inside there, almost like a compound inequality that we just got finished up with in our inequalities unit. This x is greater than or equal to negative 7. And this x will then be less than or equal to 7. Look at this in two different ways. Right there. X is greater than or equal to negative 7. Any value over here will be larger than or equal to that negative 7. Same thing going the opposite direction. So this is how we'd write our domain going from the graph to our inequality notation. In blue, I'll use this blue marker to represent it in the form of the interval notation. We have bracket negative 7, comma, 7, bracket. This would be, of course, taking this and writing it in interval notation. Now let's do the range. I'll use blue again to mark the point. So right here, for my range, my y value right here. We would know that, of course, if this is going to be a 7 and that's a negative 7, then this should be a 7. 1, 2, 3, 4, 5, 6, 7. And of course, that will be a negative 7. So our range, I will do it in red. We know that our range is going to be actually the same answer as our domain because we have a circle. It's going to be equal distance from the origin. So it's going to be a negative 7. Usually always write your negative on the left side, your positive on the right side. Negative 7 less than or equal to x. Whoops, my mistake. You guys don't make that mistake. Negative 7 less than or equal to y, my apologies, less than or equal to 7. Now again, writing this in interval notation, same exact thing. In blue, we'll go ahead here, and what it looks like is just going to be just as we saw up there. Now it makes no difference here with whether you have x or y because we're putting it in interval notation, so it's only brackets or parentheses. And remember, a bracket counts as a point that exists there. Parentheses is a point that does not exist there, or an open circle. And so, ladies and gentlemen, this is going to be the domain and range for the circle. The next example, right here, domain and range, we have a linear function we're seeing right now. We have a picture of this line that we would have, and this graph represents that. It has arrowheads on it. It doesn't stop anywhere. Arrowheads, again, remember that consistently will go in this direction and this direction. So as my y's are getting larger, my x's are getting smaller. As my y's are getting smaller, my x's are getting larger. Therefore, for this example, there's nothing that would limit my picture so that I'm bounded between two different values. For your domain, it will be all reals. That's your all real symbol. It's like an R with a line inside of it. Range, same thing, right? There's nothing that will make this range become undefined or a point where it doesn't exist or it stops somewhere like the picture of our circle that we had. So again, For this example here, what we would have now is going to be a parabola. And this parabola, again, you can see it's going to be starting right here. And that parabola that starts right there is going to be 1, 2, 3, 4, 5. So the y-intercept for this parabola is at 1, 2, 3, 4. So we'll say 0, 5. Now I'm finding that y-intercept because I see, by looking at this, that that parabola does not go anywhere below a 5. So again, now, taking a look at our domain, we'll write in blue, we see that this domain here, my x values, it counts for all these x values in here, and it counts for all these x values in here. But what about to the left and to the right of that? What about beyond this? Well, I see that I have arrowheads right here again. This represents my parabola is ever so slightly increasing to the x, to the right, and then decreasing also, but increasing and counting for all my negative x values. So again, for this example, for my domain, it counts everything. For my x, I will have all reals again. But for my range, it's going to be a little bit different. For my range, I'm only actually starting right here. I'm not starting down here, I'm not up there again, I'm only right here. So because that's the case, my y values for my range are greater than or equal to what that value is, which is our 5. So my range is y values greater than or equal to, oh, I apologize, negative 5, negative 5. I just caught this right as my second step there. I apologize, you guys. This is a learning experience for everyone. Hopefully, if you were paying attention, you saw that. And if you did, good job. So again, y is greater than or equal to negative 5. I will now put this in interval notation. It's going to be a bracket because that's a solid point. Brackets, negative 5, comma, going up towards the infinity direction. It doesn't end. Let me write that infinity sign a little bit better. And then parentheses. Remember, infinity will always get parentheses. I do not have any value below a negative 5, so it's negative 5 there. And I do not have a point where it ends, so it increasingly will go in the positive y direction. So that's domain and range today. I hope you guys enjoyed that, and good luck.